Let me describe an issue that you have probably seen. You add logging to a service, then someone asks for caching. Then security wants authorization, and suddenly your clean service class looks like a Christmas tree full of if statements. Today, I'll show you how senior developers avoid that mess. By the end of this video, you'll know how to add logging, caching, and authorization without modifying your existing services, why decorators are everywhere in modern C# code bases, and how to implement the decorator pattern step by step. This is the pattern you'll start recognizing immediately at work. This video is part of my series Code Like a Senior Dev, where we break down real-world patterns the way senior developers actually use them. Let's say we have a simple service that is represented by this iOrder service interface, which has a place order that takes in an order ID to complete. And this is how the implementation would look like. We have an order service that implements iOrder service, and we implement the place order method that contains the logic of how order would be placed. Nice, clean, simple. Now the requests start coming in. First, we need logging, then add caching, then only authenticated users can place orders. So you update the class. You write a place order method and you make sure that user is authenticated. Otherwise, you throw an unauthorized exception. And then you log it. And once you do that, you check if there is cache that exists for that particular order ID. If it doesn't exist, you log it and then you save it to the cache. And now your business logic is buried. Testing is literally painful, and every new feature that you add makes this method worse. This is the moment experienced developers stop editing the class. The decorator pattern says, don't change the service, wrap it. We add behaviors around the object, not inside it. Let's code it step by step. Alright, let's build this properly. We start with an interface, nothing fancy. iOrder service defines what the system does and not how it does it. This is important because the decorators will only work if everything speaks the same contract. Every decorator and the real service will implement this interface. Now comes the most important piece, the decorator base class. And yes, this class looks boring, and that's a good thing. Notice what's happening here. This class also implements iOrder service, which means a decorator is an order service. It holds another order service inside it. And that's the object we are wrapping. This line right here is the entire decorator pattern in one field. And we are not adding behavior here. We are just setting up the pipeline. Let's add our first behavior, logging. This class extends the decorator base class, not the real service. Inside the place order method, we'll log something. And then we call inner.placeOrder. And we need to pass order ID alongside. This line right here is critical. We are not replacing the behavior, we are just wrapping it. Logging runs before the real work, and the real service doesn't even know that logging exists. Next up, authorization. Same structure, same interface, same wrapping logic. If the user isn't authenticated, just throw unauthorized exception, and then the same logic as the earlier class. We just call the place order for the inner service that actually knows how to place order. Again, zero changes to the inner service. Security lives outside of our business logic. Now let's add caching. If the result is already cached, we short circuit the call. Otherwise, we let the request flow through, call place order, and then save the result to the cache. Notice the pattern now? Every decorator does one thing, calls the inner service, and gets out of the way. And now, let's use this. I'll create a service by creating a new order service. Now this order service gives us functionality to place order. Now, if you want to log something before placing the order, we do. Now what this does is, this would wrap the functionality that order service does with the logging decorator. We can run it now and see if everything works. So as you see, the logging happened and the logic that we had in the services place order was also executed. Going in the same direction, we can technically wrap this with different decorators like so. And by doing this, it would log, make sure that the user is authorized, cache if needed, and then call the place order in the order service. So now by doing this, the call flows through every decorator in order and then finally reaches the real service. Same functionality, 0 changes to the order service. And tomorrow, you can remove caching, add matrices, add retries without touching the business logic ever. That's why this pattern scales, and that's why seniors use it. This is why Decorator matters. They follow open-close principle. They keep responsibilities isolated. They scale without rewriting code. This is how large code bases stay sane. In real-world projects, your DI container usually wires this up for you. But if you understand this pattern, suddenly the frameworks like ASP.NET Core makes much more sense. Today we learned why adding features inside a class is a trap, how decorators wrap behavior cleanly, and how senior developers layer functionality safely. This is part of Design Pattern Code Like a Senior Dev. If this helped you to think differently about your code, hit like, subscribe, and check out the other episodes in the series. Next up, we'll tackle another pattern that senior developers use without even realizing it. See you there, and thanks for watching.